Hello friends, in my last session I told you about different types of gradients which are used in railways. Gradients are unavoidable in highways as well as in railways, and whenever there is a change in the gradient, a vertical curve is formed, and depending upon the change in the gradient, the curve can be either a summit curve or it can be a sag curve or valley curve. When two gradients meet, then a kink is formed here. This is the abrupt change. Now this point is smoothened by providing a vertical curve in the vertical plane. This is different from the horizontal curve. This is in vertical plane. And depending upon two gradients, whether positive or negative, the vertical curve can be either a summit curve. A summit curve is formed when a level track meets a falling gradient, that is zero gradient, that is negative gradient, or a rising gradient meets a falling gradient. This is positive, this is negative, or a positive gradient, a steep positive gradient meets a mild positive gradient. Then also a summit curve is formed. Summit curve is formed. Convexity is upward. Reverse of that, when the concavity is upward, then it is called the sag curve. When a falling gradient meets a level ground, or a falling gradient meets a positive gradient, or a steep falling gradient meets a mild falling gradient. These are all examples of sag curve or valley curve. Here the concavity is upward, here the convexity is upward. Length of vertical curve depends upon the algebraic difference between two gradients, gradient 1 and gradient 2, and also whether the curve is summit curve or valley curve or sag curve. And the equation which is used to determine the length of vertical curve is L is equal to A upon R into 30.5. Now 30.5 or 100 feet is taken as the chain length. A is the algebraic difference between the two gradient, and R is the rate of change of gradient. This R is 0.1 for summit curve and it is 0.05 for sag curve. Say for example, a rising gradient of 1%, 1 in 100, meets a falling gradient of 1 in 200. What is the length of the curve? Length of vertical curve. Now the length here, G1 is 1%, G2 is 0.5%, 1 in 200, and therefore A is 1 minus 0.5, that is 1.5%. And therefore the length of the curve will be 1.5 because it is a summit curve. So 0.1 into 30.5. That is something like 460. 457.5, or you can say 460 meter. This is the length of the curve required to be set to have a smooth entry and exit from these two gradients. Now, as you can see here, this length of the curve is quite large and it has difficulty in laying in the field also. And therefore, the new method or new stipulation on Indian Railways is to calculate the length of the curve by using this equation. L is equal to R into Q. R is the radius of the vertical curve and Q is the same as A, that is algebraic difference between the two gradients. Now this value of R depends upon the gauge. What Indian Railways suggests that no vertical curve is required if the algebraic difference between two gradient is less than or equal to 0.4%. Beyond that, you need a vertical curve. And the radius of the curve for broad gauge line of A, B and C, D and E, this minimum radius of the curve is specified as 4000 meter, 3000 meter and 2500 meter. These are the minimum radius to be provided on vertical curve for BG lines. In case of meter gauge lines, for all routes, this value is 2500 meter. So if you take the same example that a rising gradient of 1 in 100 meets a falling gradient of 1 in 200, so Q is now 1.5, radius of the curve is 4000 meter, let us say group A line, 4000 meter, then in that case this L will be 1.5 into 4000, that is 60 meter, divided by 100. This is in radian. This is taken in radian. So 1.5% is taken 1.5 upon 100. Now what has been the experience on Indian Railways is that this is easy to set in the field and this is sufficient also to take care of the acceleration force, radial acceleration because of movement of the train on a vertical curve, sag curve or the summit curve. This equation does not differentiate between a summit curve and a valley curve. It is same for both. 60 meter is sufficient to provide a smooth entry between these two gradients. So this is the new method of finding the length of vertical curve on Indian Railways. Now once you get the length of the vertical curve, the next step would be setting of the curve. Let us say AB is a vertical curve and this is the apex point E and this is the point on the curve, let us say F, and if you join these two ends, that is the point here. You can call it, let us say G. Now setting of the vertical curve basically means to determine the RLs of different points on this vertical curve. And there are two methods of doing that. One is tangent correction method and another is chord deflection method. Tangent correction method is more popular because it is easy to use in the field than chord deflection method, but both can be used. The basic difference between these two methods is like this, that you determine the length of vertical curve between A and B, divide this length into n number of equal parts. Let us say you have a point here, you have a point here, 3 on half of the length. Now in the chord deflection method, what we do, you find the RL of this point, you find RL of this point, and then find out RL of, let us say this is point C, this is point D. You find out what is the RL of this point, because you know the RL of A, RL of B, so it will be uniform, increase or decrease in the RL, and then you find out what is this chord deflection. C0, D0, so that from D point you move to the point on the curve, and this is X, this is X distance, this is the length of the curve, total length of the curve. Then this offset is calculated using this equation, x into L minus x upon 2r. At any distance x, you can find out what is the chord, what is the offset from the chord, so that you get the point on the vertical curve. That is chord deflection method. In the tangent correction method, the procedure is like this, that you determine the length of the vertical curve, divide into equal parts. Now you get the RL of not C, but RL of C point is taken here. C point is taken here on the tangent. D point is taken here on the tangent. So you know the RL of this point, you know RL of the highest point, and change also. Find out what is the RL of C point, and then you take this tangent correction. Determine CC0. Now this CC0, that is basically in the case of vertical curve, it is laid as a parabola, second degree parabola. Y is equal to C into x square. The basic idea behind this equation is that rate of change of gradient should be constant. So if you differentiate this equation with respect to x twice, you get C. d2y upon dx2 is C. That is constant. Now this value of C here is G1 minus G2 upon 4 into N. That is the value of C. G1 is the first gradient, G2 is the second gradient, N is the number of chainage, number of chain length, you can say, number of chain length in the half of the length of the curve. So here in this case, what I have shown here, A, C, D, G. AG is the half of the length of the curve, so 1, 2, 3, N will be 3. If you divide total into 6 parts. So that is the basic difference between two methods, but both methods will give the same elevation of these points on the curve. And once you know the RL of these curves, you can set in the field. Now let me take the same example, that a vertical curve is formed when a rising gradient of 1 in 100, G1 is plus 1%, G2 is minus 0.5%. When a rising gradient of 1%, 1 in 100, meets a falling gradient of 1 in 200 on a group A lines of broad gauge. Find out the length. Length we have found out 60 meter. And let me explain these two methods in the same example. So length of the curve is R into Q. Q is 1.5 upon 100. R for a group A line is 4000 meter, and therefore L is 60 meter. That is the total length A to B. Length of the vertical curve is 60 meter. Let us divide this into 6 parts. So each interval is now 10 meter. Now let me first try with the chord deflection method. So in the chord deflection method, let us assume that the RL of this point E is 100 and the chainage of this point is 1000 meter. Let us say chainage of the highest point, because this point is known in the field because you have two gradients sloping. So chainage of E is 1000 meter and RL of E is 100 meter. Let us assume. So what is the RL of A? RL of A at a slope of 1 in 100 and 30 meter. So chainage of A, chainage of A point, that is starting, will be 1000 minus 30, that is 970 meter. And this is 970 meter. And this is 1000 plus 30, 1030 meter. Its RL is 100 meter, and therefore the RL of A will be 100 minus 30 into 1 by 100. 99.7 meter, 99.7 meter. This is 99.7 meter. And similarly, RL of B is 100 minus 30 into 1 by 200. That is the slope downward. So it will be 99 minus 85 meter. So RL of this point is 99.85 meter. So in a length of 60 meter, there is a change in the RL of 99.85 and 99.7. So change in the RL for 10 meter length, because we have to draw offset at every 10 meter. That will be 99.85 minus 99.7 divided by 60 into 10, 0.025 meter. Now, this is lower, this is higher. So C, the RL of C will be 99.7 plus 0.025 meter. So RL of C will be 99.7 plus 0.025 meter, that is 99.725 meter. Similarly, RL of D will be RL of C plus 0.025 meter, and so on. You can make a table. You can make a table here like this. Chainage. Then the point RL of this point, then offset. Offset basically is CC0, because we are now discussing chord deflection method. So first point is A, its chainage is 970, RL of this point is 99.7 meter, offset for this is 0 because x is 0, that is the starting point, and therefore in the next column you can write point on the curve, point on curve, and RL of the curve, RL of point on curve. This type of table will be helpful. So point on the curve is A itself, and its RL remains same because there is no offset. This is the starting point, 99.7 meter. Now take the second. Second is at 980 meter. So next point is C. RL of this point C is 99.725 meter. Offset. Now offset you can find out using this equation. Offset is x into L minus x upon 2R. X is 10, L minus x is 50 because L is 60, divided by 2 into 4000. This is 0.0625 meter. So if you add this 0.0625 to the RL of C, you will get RL of C0. So offset is 0.0625, point on the curve is C dash, and therefore its elevation or its RL will be 99.7875 meter. That is how you can continue. You can have the second point D, its RL will be this plus 0.025, because every 10 meter you are increasing by 0.025 height, and then this D0 can be, X will be 20 now, 20 into 40 divided by 2 into 4000, that will give you the offset. And add that to this, you get point D0. This is chord deflection method. You can complete this table for all the 6 points from A to B, and that is the setting of the curve. Once you know the RL, you can set the curve in the field. In the tangent correction method, what we do differently is that you know the RL of this point A, that is 99.7 meter, and its chainage is 970 meter. Now you find out what is the RL of this point. Now C is not taken here, but C is taken here. Now chainage of C, 970 plus 10, that is 980. RL of C, 99.7 plus 10 into, now here it will be plus, okay, 10 into 1 by 100, that is the slope, so it will be 99.8 meter. That is the RL of this point, 99.8 meter. Now you find out what is the tangent correction to get the point C0 on the curve, and this is given by y is equal to C into x square. Now x here is taken in terms of chain length. Here in our case chain length is 10 meter. So x is 1, 2, 3, 4, 5, 6, and therefore C is taken as G1 minus G2 upon 4n into chain length. So G1 is 1.1%, G1 is 1%, G2 is 0.5%, so this is 1.5 divided by 100 in radian into 4 into n. N is the number of chords, number of chains in half length of the curve, that is 3, into 10 meter. This is 0.0125 meter. So y is 0.0125 x square. The first correction CC0, the first correction will be when x is 1, 0.0125 meter. And therefore, the RL of C0, RL of C, that is 99.8 meter, minus this correction 0.0125 meter, and that is 99.7875 meters. And if you check, this is exactly the same what we got from chord deflection method. So idea is, or the purpose of setting the curve is to get the RL of all these points on the curve. Similarly, you can find out RL of D0, and for that first you find out what is the RL of this point D on the tangent. is on tangent. Okay, we are discussing tangent correction method. So RL of D will be 99.8 plus 0.1, that is 99.9 meter. 0.1 for every 10 meter up to E, and then you fall at a rate of 0.05. The correction will be now DD0. Next correction will be 0.0125 into x square. Now x is 2 chain length into 2 square, and this is 0.05 meter. So RL of D0, which is on the curve, will be RL of D 99.9 minus 0.05, that is 99.85. 99.85 meter. Again, you can compare this RL is same as what you got from the chord deflection method. So that is how we set the curve by two methods, tangent correction method and chord deflection method. Both are equally good, but tangent correction method is more convenient to lay in the field. So that is how the vertical curves are designed in railways. Thank you very much for watching this video. If you have any question, you can write in the comment box.